Good morning, good afternoon, good evening. This is Mr. Payne bringing you more linear modeling. Unit 4, Lesson 7. I want to go over some critical linear facts from Unit 4, Lesson 6. All linear models are in the form y equals mx plus b have two parameters, the slope and the y-intercept. The slope is our m, the y-intercept is our b. I know we're really beating this in, but we have to make sure that you understand this concepts. The slope always tells us how fast the output is changing relative to the input. It's our rise over run. It's our delta change, our change of y over our change of x. The y-intercept always tells us how much we start with, our output's starting value. That is where x equals 0. Let's take a look at exercise number 1. A warehouse is keeping track of its inventory of cardboard boxes. At the beginning of the month, they had a supply of 1,275 boxes. They use boxes at a rate of 75 boxes per day. So I want to underline some key facts in this little reading here that will help us. They had a supply of 1,275 boxes. That's what they start with. They use the boxes. I want you to circle the word use. Rate of 75 boxes per day. So let's go to question B first. I would like you to pick which of these following linear equations models the number of boxes left. So I want us to think back to our lesson 6. Think about what they're giving me. They're giving me some really good key information. They're giving me 75 per day. So I'm changing each day, for every one day, I'm changing by 75 boxes. I'm beginning with 1,275 boxes. The other word that I want you to think about is use. What does the word use mean to you? Use. If I'm using something, am I having more of it or less of it? So with all that being said, using these keys, the word use, 75 per day, that can be written as a ratio, and 1,275 boxes, my B, that's where I'm going to begin. Let's pick out the right choice. Let's see if 2 is it. Is 2 1,275 times D plus 75 the correct answer? No. This is my starting point, not my slope. So that is not going to be the answer. Let's put a line through that one. Now let's go to 1 and let's go to 4. The word use means I'm going to be subtracting by 75 boxes per day. Well, what is my slope? In both of these cases, my slope is a positive slope. So it's not going to be going down. So both of those can be eliminated. It is choice 3, and let's determine it. It is written a little funny. We could rewrite it as n equals negative 75d plus 1,275 is my starting point. With that being said now, we're going to go back to A. We're going to say, okay, how many will be used in 10 days? So I have 75 times 10 plus my 1,275. 10 days goes in for D. 75 times 10 is 750 plus my 1,275. And it's going to give me an answer. I'm sorry, it's going to be a negative 750. And it's going to give me an answer of 525 boxes will be left. C. If the warehouse needs to order more boxes than their supply reaches 150, how many days can they wait? Well, my 150 is not going to be my days. I want to know on what day I need to order more boxes. So my 150 is going to go in for my N. It's going to be 150 equals negative 75N, or D, plus my 1,275. And I'm basically going to just go ahead and continue to solve for that. So minus 1,275 on both sides. And that's going to leave me negative 1,125 equals negative 75D. Go ahead and divide by negative 75. And on day 15, I'm going to have to order more boxes. On day 15, we will have to order more boxes. I would like you to try D on your own. Oh no, I lied. I want you to save D. I'm sorry. I want you to save D so that we can do that in class as some group work. It's a little bit more complicated. You have to find out a couple things before you can go ahead and get your answer. So let's hold on to D. Exercise 3. Biologists estimate the number of deer in Rhode Island in 2003 was 1,028. And in 2008, it had grown to 1,488. Biologists would like to model the deer population P as a function of the years T since 2000. So a couple things that are a little tricky here. The data that they give us does not include the year 2000. So eventually we're going to have to figure out how many deer were actually there in the year 2000 or estimated to be there in the year 2000. Let's start off with question A. Represent your data as two coordinate points. For wherever I see my 2003 and my 2008, I'm going to just go ahead and use the ending part of the year. I'm just going to use 3. And then I'm going to use 8. So I'm going to have the point 3, 1,000. And I'm going to use 8, 1,488. Okay? Those are my two coordinate points. Notice that the 3 represents 2003. The 8 represents 2008. Calculate the rate of change from 2003 to 2008. So I'm going to simply just use my formula, y2 minus y1 over x2 minus x1. It's my slope formula, my rate of change formula, also known as my slope, don't forget. So my y2 is going to be 1,028 minus, I lied, let's back that all up. My y2 is 1,488 minus 1,028 over 8 minus 3. That's going to give me 460 over 5, which is going to give me 92 deer per year. So how many deer does this model predict were in Rhode Island in the year 2000? What does this represent about the linear function? So we found out that there were 92 deer per year that it increased. I want to know how many deer were there in 2000. Well, from 2000 to 2003, that was 3 years. So I'm going to have to say 92 deer per year times 3, which is going to give me 276. Total deer would have grown from 2000 to 2003. So what I need to do is take what I had in 2003, which is 1,028, minus the 276 possible deer, and that's going to give me an answer of 752 deer in the year 2000. D. Determine the linear relationship between the deer population and the year since 2000. So I'm using my information from the year 2000. That's my starting point because that's where my x is 0. And so that's the information I just found out, plus my slope, don't forget. So if I wanted to write that out, it is going to be population of deer equals 92 times my t, which is my year, plus 752. remembering that this is my starting point, this is my slope. And because my deer are increasing in population, that is a positive 92. Now, if this question said they are losing deer population, that would be negative 92. I would like you to go ahead and now try F on your own. Calculate how many deer this model would predict in the year 2014. Exercise 4. Water is draining out of a bathtub such that a volume still left G gallons is shown as a function of the number of minutes, M, it has been draining. Calculate the average rate of change of G over the interval 0, 2. So I have 0, 62, and my other point would be 2, 28. If we use our rate of change formula, it would be 28 minus 62 over 2 minus 0. 28 minus 62 is going to give me a negative 34 over 2, which is going to give me a negative 17. That's 17 gallons per minute between the interval of 0 and 2. Now if I wanted to do it again, in B, calculate the average rate of change of G over the intervals 2 to 4, I'm going to say, all right, 2, 28, and 4, 12. Rate of change formula, 12 minus 28 is going to give me 4 minus 2, which is going to give me a negative 16 over 2, which is going to give me a negative 8 as a rate of change between intervals 2 and 4. Why can we say that the relationship between M and G is not linear? Well, if you notice, our slopes, one is negative 17, the other one is negative 8, they are not consistent. And we know that this is not linear because of that lack of consistency, so not consistent. It's all about the slope. The slope has to be consistent or go up on an even interval or a consistent interval in order for this to be a linear function. This is not a consistent slope, therefore it is not linear. I hope you have a great night. Make sure you watch all these videos, write down your WSQs, and I do miss you. I'm recording all this stuff during our storm, so I hope everybody's safe. Take it easy.